Okay, so hello everyone. This time it's going to be video number 5 of this series. This is my maths homework. Okay, let's do the first questions. Okay, so suppose you have this series 2 by 5 plus 3 by 5 squared plus 2 by 5 cubed plus 3 by 5 to the fourth power, and it keeps on going like that. Now this series, it can be written as 2 by 5 plus 2 by 5 cube plus 2 by 5 to the fifth power, and it keeps going like that, plus 3 by 5 squared plus 3 by 5 to the 5 to the fourth power, and it keeps on going like this. So this can be written as a upon 1 minus r, which is going to be 2 by 5 upon 1 minus 1 by 5 squared, plus 3 by 5 3 by 25, so 3 by 5 squared upon 1 minus 1 upon 5 squared. All right, so well, that can be further written as what happened. Okay, that can be written as erase some stuff. Okay, so that can be written as when you multiply both top and bottom by 25, you can write it as 10 upon 24 plus 3 upon 24. It's going to be 13 upon 24. I think that's correct. Let's go to the second question. I'll just erase this first. Okay, that's nice. Okay, the next question is 1 by 3 plus 1 by 5 square plus 1 by 3 to the third power, and keeps on going like this. So once again, it's just two GPs. The first one is going to be 1 by 3 plus 1 by 3 to the third power, then 1 by 3 to the fifth power, it keeps on going like that, and then 1 by 5 squared plus 1 by 5 to the fourth power plus 1 by 5 to the sixth power, and it keeps on like that. This can be written as 1 by 3, which is the first term, upon 1 minus the ratio is going to be 1 minus 9, I think, and this is going to be 1 by 5 square is just 1 by 25 upon 1 minus 1 by 5 square, so 1 minus 1 upon 25. Okay, so that's going to be equal to, when you multiply by 9, you get 3 upon 9 minus just 8 plus 1 upon 25 minus 1 just 24. Okay, which can be written as 9 by 24 plus 1 by 24, which is going to be 10 upon 24, which is nothing but 5 upon 12. Okay, that's nice. Let's go to the next question. Okay, so we have to prove that 9 to the 1/3 power plus 9 to the 1 by 9 power. Okay, so it's not plus, it's into 9 to the 1 by 9 power into 9 to the 1 by 27 power, so on till infinite terms. This is going to converge to 3. Okay, this is very easy, because you can see that it's going to be 9 to the 1/3 plus 1 by 9 plus 1 by 27, and it keeps on going like that. This power, this is supposed to be equal to 3, right? That's just basic indices, nothing else. Wait, what? There's nothing. Okay, which is going to be 9 to, let's see, the first term is 1/3, the ratio is also 1/3, so this is going to be equal to 9 to 1 upon 3 minus 1 is just 2, which is which is equals to 3, right? So yeah, that's nice. This was easy. Let's go to the next question. Just scroll down a little bit. Okay, so the next question is, prove that 2 to the 1/4 times 4 to the 1 by 8 times 8 to the 1 by 16 times 16 to the 1 by 32, so on it till infinite terms, is supposed to be 2. Okay, so 2 to the 1/4, and this is 4 to the 1 by 8, and then 8 to the 1 by 16. Okay, this is it's weird. Okay, so you can see that these 2, 4, 8, 16, these are basically in GP, and 1 by 4, 1 by 8, 1 by 16, these also are in GP. Well, let's see what we get. We get 2 to the 1/4 power plus, well, 4 is going to be 2 squared, so 2 upon 8 plus 8 is 2 to the third power, so it's going to be 3 upon 16, and 4 upon 32. It keeps going like that. This is till infinite terms, and that's going to be equal to 2. Well, this is weird. 1 by 4 plus 2 by 8 plus 3 by 16. Okay, Well, there's no, this does not seem like it's having any kind of common ratio. Um, yeah, every time we are going up with 1 by 2. Yeah, that's. Huh. Uh, what are we even supposed to be doing with this? I mean, this is not a good series at all. This is supposed to be. This is just n upon 2 to the n plus 1 power, something like that. And we want to prove that this is going to be equal to 2. So for that we have to prove that this is going to get to 1. Well, I don't see any instant connections over here. 1 upon 8. What can we even do with this thing? Did we do it incorrectly in any way? We got 2 cubed, 2 to the third power times 1 by 16 is 3 by 16. I'm pretty sure we did it correctly. So we want to prove that this is supposed to be equal to 1. Well, this would be very difficult if we were not humans and we were not smart enough to guess how we are going to do it. Okay, so 1 2 3. Okay, so what I'm going to do is that I'm going to write it as 1 by 4 plus 1 by 8 plus 1 by 16 plus 1 by 32, so on. Then plus, you see this 1 by 4, it got used up. Now we are going to use up the another 1 by 8 which we have, another 1 by 16 which we have, another 1 by 32 which we have, and keeps on going like that. And then these both these things, these got used up, and 2 of these got used up, so you are left with just one of them. So you got 1 by 16 and then 1 by 32, and yeah, you can see where it is going. Alright, so this is going to be equal to, the first one is going to be 1 by 4 upon 1 minus 1 by 2. This is just 1 by 2 itself. And the next one is going to be 1 by 8 upon 1 by 2. Oh, that's nice, that's sweet. It's 1 by 16 upon 1 by 2. So because the common ratio is same in all of these this series, you can see that the sum of their infinite terms, that's okay, those sums are also coming to be an GP. So just clean this up. Okay, so I mean, this was a really good one, really made me think. Okay, so this will keep on going like that. So this can be written as, well, 1 upon half is just 2, so 2 into 1/4, 2 into 1/4. Okay, that can be written in a better way. That can be written as 1 by 2 plus 1 by 4 plus 1 by 8, and it keeps on going like that. And we know this is that famous series which converges to 1, right? Many people know about it. So, and if you want to go with complete sincerity, you can also do it like this. We know it's going to be 1. Okay, cool. So let's move to the next question. If SP denotes the sum of the series 1 plus r to the pth power plus r to the 2p plus r to the 3p, it keeps on going till infinite terms. And SP, the sum of the series, small sp is the sum of the series 1 minus r to the p power plus r to the 2p power. So these are alternate positive, alternate negative. So instead of going up by r every time, they are getting multiplied by negative r every time. Okay, prove that sp plus small sp is going to be 2. 2s 2p. Okay, that seems good. So just write this down once again. So sp, what happened to this? Okay, so sp, capital sp, is going to be equal to 1 plus r to the p power plus r to the 2p power, and keeps on going like that. And then small sp, let's call this capital S, big one. Okay, so it's supposed to be 1 minus r to the p power plus r to the 2p power, and then minus, and then plus, and then minus, and keeps on going like that. So when you add them up, you get capital SP plus small sp. That will be 2 times of 1 plus r to the 2p power plus r to the 4p power and it will keep on going like that, which is nothing but 2 times. Well, if I were to replace um, this p by 2p, I would get this thing, right? I mean, s of 2p, what would that be? You just have to replace this p by his 2p everywhere in this series, so you will eventually get this thing. So this is going to be 2 times of s of 2p. Yep, that's it. It was easy. Didn't have to think much about it. Okay. What the heck is happening? Okay, let's go to the next question. The next question is, find the sum of the terms of an infinite decreasing GP in which all terms are positive. Find the sum of the terms of an infinite decreasing GP. Okay, infinite decreasing GP. Okay, that's nice. All terms are positive. The first term is 4. Okay, the first term is 4. And the difference between the third term and the fifth term is equal to 32 by 81. Huh. Okay. So the fifth term is going to be the smaller one. So the third term is bigger. So AR squared. Why even write AR squared? Let's write 4 times R squared minus the fifth term, which is going to be 4 times R to the fourth power. That's supposed to be equal to 32 upon 81. Okay, that's nice. We just cut off 4 from everyone. So R squared minus R to the fourth power is going to be equal to 8 upon 81. Okay, so this is almost a quadratic. Let's call R squared to be equal to, say, something m. So you will have m minus m, just multiply by 81. So 81 m minus 81 m squared is equal to 8, or you have 81 m squared minus 81 m plus 8 is equal to 0. So now we want to factor 81 into 8 into two things which add up to 81. Well, why does this keep happening? Okay, this is looking to be a difficult one. Okay, you could use the quadratic formula. Maybe that's the better way out. So just use the quadratic formula, that will help. Okay, so here we get m equals to r square, obviously, and m is equal to, using quadratic formula, you get positive 81 plus minus root p squared, 81 squared minus 4 times of this thing times this thing, so 32 into 81 upon 2 into 81. That's going to be 81. There are a lot of 81s over there. 81. Now what I'm going to do is that I'm going to factor out a 9 squared from each of these things. So I will get plus minus 9 square root of, one of the 81 is gone, so 81 minus 32 upon 2 into 81. Well, what's 81 minus 32? This will be 11 minus 2 is just 9, and you got 7 minus 3 is 14. Oh, that's it. So this is supposed to be 7, so this is going to be equal to 7, right? So 9 into 7, so you will have this. Erase this, now we have no need for it. You will have 81 plus minus 9 to 7 is 63 upon 2 into 81. Okay, well, yeah, that's how it's supposed to be, and yeah, that's correct. I mean, no problem, both values will work. So this is going to be equal to, well, if you take minus 63, then you get 11 minus 3 is going to be, what am I supposed to find? Find the sum of the terms of an infinite decreasing GP. Oh, is equals to 32 upon 81. Well, okay, that's, I mean, fine, but well, doesn't that seem weird? I mean, we are getting this value for r, which doesn't look good. Okay, so did we do it correctly? Well, whatever, now we have done it, so just go along with it. So 21 minus 3, that's going to be equal to 18 upon 2 into 81, which is, well, you got 81 into 18 into 9, so just 1 by 9, or you have 81 plus just fact, you know what, we could reduce this further, just reduce by 9 on both sides, so you will get 9 plus minus 7 upon 2 into 9 is 18. So this can be, you could have 2 upon 18, which is 1 by 9, or you could have 16 upon 18, which is 8 by 9. So the common ratio can be 1 by 9 or 8 by 9. Well, that's nice. Okay, so you have ratio equals to 1 by 9 or 8 by 9. So our sum of the series is going to be equal to sum of the infinite series, that's going to be equal to a upon 1 minus r, which is, so a is 4, 1 minus r, well, suppose it is 1 minus 1 by 9, then this would be 9 minus 1 is going to be 8, so 4 into 9 upon 8, that's supposed to be 9 by 2, or it could be 8 by 9, so 4 upon 1 minus 8 by 9, yes, that can be 9 minus 8, which is 1, so yeah, that's it. So 9 into 4, which is 36. Not bad. Right, so both of them do work, right? 1 by 9 and 8 by 9. Maybe I should actually calculate the third and fifth. Oh, let it be. What could be wrong? If we did get a perfect square in that square root, well, this should be correct. Okay, move on to the next one. Find an infinite GP whose first term is 1. Okay, so first term is 1, a is equals to 1, and each term is the sum of squares of the terms which follow it. Oh, each term is the sum of squares of the term which follow it. So suppose that this series is going to be 1, then you multiply by some ratio r, then it's going to be r squared, then r cubed, it keeps on going like that, right? And it keeps on going till n terms, so you have r to the n minus 1 over there. So this nth term is going to be just say you will also have r to the n, so this is the n plus 1th term, which is going to be equal to the sum of squares of these. Wow, let's just see what we get. So you get r to the n is going to be equal to the sum of the squares of these things, which is 1 plus r squared plus r to the 4th all the way till r to the, well, r to the 2n minus 2. So it's going to be equal to, well, the first term is 1, the ratio is r squared. How many terms are there? N terms. So it's supposed to be r to the 2n, then minus 1 upon r squared minus 1. Okay. So what can we get from that? Well, you can get that r to the n plus 2 minus r to the n is supposed to be equal to r to the 2n minus 1. Not sure how that helps. So find an infinite GP. This first term is 1, and each term of the sum of all the terms. Wait, what? Oh, there is nothing about that square. Why did I even think? Okay, sum of all the terms which followed. It's not telling anything about squares or anything. Sorry, my bad. There are no squares in this. Okay, it's just 1 plus r squared all the way till r to the n minus 1. That's just going to be 1 into r to the n minus 1 upon r minus 1. Okay, that looks simple. So from this we will get r to the n plus 1 minus r to the n is equals to r to the n minus 1. Okay. What now? You want to find the value of r somehow. Okay. First term is 1, and each term is the sum of all the terms which follow it. Wait, what? which follow it. Oh man, I made more than one mistake in this. Okay, this is a complete mess of words. So not the previous terms but the terms which will come next, right? So come on. Okay, so there you go, you have 1, you have r, you have r squared all the way till something, say r to the um, r to the n maybe, yeah, whatever. So you have r to the n, then you have r to the n plus 1, then you have r to the n plus 2, and it keeps on going like that. And what this condition says is that you have r to the n is equal to r to the n plus 1 plus r to the n plus 2 plus r to the n plus 3, and keeps on going like that, which is nothing but r to the n plus 1 upon 1 minus r, because here we are assuming that the modulus of r is supposed to be less than 1. We don't know if that is true or not, but okay, we need to solve this problem first. Okay, so you have this thing, so you can cancel an n from both of them, so you just get what you get 1 equals to r upon 1 minus r. So you have 1 minus r equal to r, or in other words 2r equal to 1, so r equals to half. So this only works when the ratio is going to be half. So this GP is going to be 1, 1 by 2, 1 by 4, and it keeps going like that. And yes, this does work. Every term is the sum of all the terms which will come next to it. Right, when you add these terms up, you just get this term. When you add these terms up, you just get this term. I mean, yeah, that's nice. That's nice. Why is this happening? Okay, let's go to the next question. The sum of first two terms of an infinite GP is 5, and each term is 3 times the sum of its succeeding terms. Find the GP. Okay, the first two terms of an infinite GP is 5, so you have a plus ar is equals to 5. Okay, and each term is 3 times the sum of the succeeding terms. So suppose this thing is ar squared, and so on till ar to the n, then ar to the n plus 1, and keeps on going like that. So you have a r to the n is supposed to be equal to the sum of all these terms, which is ar to the n plus 1 upon 1 minus r, because here we are assuming that the ratio is having its mod less than 1. Okay, so cancel off these things and cancel this away. So you have also this thing. So once again you still get the same thing, right? R is going to be equal to half. And the sum of the first two terms is 5. So when you put r equals to half in this thing, you get a plus half a equals to 5. So 3 by 2 a equals to 5 implies that a is going to be equal to 10 upon 3. So this GP should look something like this. The first term is 10 and the ratio is half. The first term is 10 by 3. The ratio is half, so you get 5 by 3. And yes, this is 5. And then half of that, which is 5 by 6. And then 5 by 12, and it keeps going like that. Okay, that's nice. Let's go to the next question. Express the recurring decimal point. Wait, we have already done this question once, so I'm not going to do it. If you want to know how to do this, just watch my previous videos. I've already done this question once. The next question is find the sum of the following series to infinity. So you have 1 minus 1 by 3 plus 1 by 3 squared minus 1 by 3 cubed. Okay, so you can see that the pattern is like something like this. You have 1, and then you multiply by minus 1/3, so you get minus 1 by 3. Once again multiply by minus 1/3, so you get plus 1 by 3 squared, and it keeps on going like that. So this is supposed to be equal to 1 upon 1 minus of minus is just plus 1 upon 3, which is 3 upon 4. Yeah, easy. To the next question, 8 plus 4 root 2 plus 4. Oh, okay, getting it. So 8, then you divide by root 2 and you get 4 root 2. Once again you divide by root 2, you get 4, and it keeps on going like that. So it's supposed to be equal to 8 upon 1 minus the ratio, which is 1 by root 2. So this will be equal to 8 root 2 upon root 2 minus 1. We can rationalize this. So you will get 8 root 2 times root 2 plus 1, which is 8 times 2 is 16, and then plus 1, so plus 8 root 2. Yeah, easy. Let's do the next question. Erase everything first. Yeah, even if we didn't erase it, was okay. Okay, the nth term of a GP is 128 and the sum of its n terms is 255. Its common ratio is 2 and the first term is okay. That's nice. So the nth term, which is going to be AR to the n power n to the n minus 1 power, that's 128. The sum of its first n terms is 255. The sum of the first n terms is going to be a into r to the n minus 1 upon r minus 1. That's supposed to be equal to 255, which can also be written as the nth term times the ratio minus 1 upon r minus 1, which is 255. So you can just put that in there. So you get 128 r minus 1 upon r minus 1 is supposed to equal to 255. Right, first two equations done. Let's see what we get from this. So you get 128 r minus 1 is equals to 255 r minus 255. So that gives us 254 is equal to, well, 15 minus 8 is equal to 7, and then you have 4 minus 2 is just 2, and then 127 r. That looks correct. So you get r equals to 2. Easy as that. Why is this happening? Okay, so the ratio is 2. What are we supposed to find? If its common ratio is 2, wait, we just found that, whatever. Okay, then its first term is why did we even, okay, so the ratio is already given to us anyway. So the nth term is 128, which is like a times r to the n minus 1 is equals to 128. Alright, sum of its n terms is 255. You do know the ratio. You also know that a times r to the n minus 1 upon r minus 1, that's 255. What I'm going to do is that I'm going to divide these two, so we can eliminate this first term and then we will be able to find the value of n somehow. Yeah, that shit, I think we missed something. Yep, we definitely missed something. Oh, now I get it. In the last formula, we actually, what we did was that we actually manipulated it like this. Well, that's incorrect. It should be something like that. So sorry, I don't know why I'm making so many of mistakes right now. So what you get is a n, which is the nth term, times the ratio minus a upon r minus 1. This thing is the sum of n terms, which is 255, and then this thing is going to be 128. So you get 128. R is going to be 2 minus a. Well, now we know that a is going to be 1, but still let's just formally do it. Into 2 minus 1, right, because r is 2, so it's equal to 255. So you get a is equals to 256 minus 255 is just 1, as we expected. We did the question incorrectly and yet we got the correct answer. How nice. Okay, if the sum of an infinitely decreasing GP is 3, okay, and the sum of the squares of its terms is 9 by 2, the sum of the cubes of its terms is okay, let's do it. So you got a plus ar plus ar square and keeps on going like that. It's supposed to be equal to 3. So you got a upon 1 minus r is going to be equal to 3, and then you have the sum of its squares is sum of the squares of its terms is equals to 9 by 2. So a squared plus a squared r squared plus a squared, this is r, a squared r to the 4th power, and it keeps on going like that. Which is a squared upon 1 minus r squared, that is 9 by 2. Okay, so let's just square this first so that we will be able to find the value of r somehow. So you will have a squared upon 1 minus r whole squared is equals to 9. Okay, now let's divide these both equations. So we will get y. Okay, so what do we get when we divide these? So you get, well, a squared they get cancelled. You get 1 upon 1 minus r whole squared upon 1 minus r into 1 plus r. That's going to be equal to 9 upon 9 by 2, just 2. Yep. So okay, you can send this to the top. So you get 1 minus r upon 1 minus r squared. That's just, well, you just get 1 plus r remaining. And you have 1 minus r is equal to 2. So 1 plus r is equals to 2 minus 2r. So you get 3r equals to minus 1. No, sorry, 1. Oh, sorry. That gives us r equals to 1 by 3. Okay. The sum of the cubes of these terms is, okay, so sum of the cubes. So first information which we got is r equals to 1 by 3. Now we can just plug that in this equation. A upon 1 minus r is equals to 3. So let's just plug this in this equation. So a upon 1 minus 1 by 3 is supposed to be equal to 3. So you get a by 2 equals to 1, or a equals to 2. Okay, that's nice. So a is equal to 2. That's the second piece of equation which we second piece of information which we have. So a equals to 2. So now we can just generate the whole series. So when you sum of the cubes, you just get sum of cubes sum of cubes, that's going to be a cubed upon 1 minus r cubed. Okay, which is going to be 8 upon 1 minus 1 by 27, which is 8 into 27 upon 27 minus 1 is 26. Whatever this answer turns out to be, I'll just reduce this 413. It's going to be 8 and 28, so 108 upon 13, whatever that is. Okay, that's going to be our answer. Let's go to the next. Why is this happening? Okay, so let an be the nth term of the GP of positive numbers. Okay, so an is the nth term of the GP of positive numbers. Let summation from n equals to 1 to 100 of a sub 2n be equal to alpha. I think we have, oh no, yeah, I think we have done this, but what, we'll just do this twice. It will still make it will still be cool. So you have all the even terms added up till 100, right? So all the first 100 even terms added up, that is going to be alpha. So you just get a2 plus a4 plus, yeah, it keeps on going like that till you get a 200, which is nothing but a2 times 1 plus r squared plus r to the 4th, and it keeps on going like that till 100 terms. So eventually you will get something like what's this, r squared, so 100 and I think 198. Yeah, this is supposed to be equal to alpha. Okay, and then you have all the odd terms, all the first 100 odd terms. You have a1 plus a3 all the way till these 100 things. So you put 100 in this, you get 200 minus 1, which is 199. I mean a199. This is equal to beta, so you get a1 into this same thing, 1 plus r squared all the way to r to the 198. That's beta. So this is obvious. You just divide these. These factors will get cancelled. You got a2 upon a1, which is equal to the common ratio. So you will just get alpha upon beta is equal to the common ratio. That's easy. That's easy to show. Okay, let's go to the next question. The sum of the first two terms of a GP is 1. And every term of its series is twice of its previous term. Okay, so every term in this series is twice of its previous term, so the ratio is going to be 2. Sum of the first two terms of a GP is 1. Okay, so a plus 2 times of a is 1, which means that a is 1 by 3. So you get this series 1 by 3, 2 by 3, 4 by 3, it keeps going like that. So the first term is, well, the first term is 1 by 3, so obvious. Okay, go to the next question. If ABC are in AP and their absolute value or mod are less than 1, and x is equals to this thing, y equals to this thing, oh, okay, then show that x, y, z shall be in x, y, z are in harmonic progression. Okay, really, let's just do this. So you have x is equals to 1 upon 1 minus a, because the magnitude of a is less than 1. Similarly, y equals to 1 upon 1 minus b, z equals to 1 upon 1 minus c. So from this we can say that 1 upon x is 1 minus a, so that means that a is equals to 1 minus 1 upon x. Similarly, for everything else, b equals to 1 upon 1 minus y, and c is equals to 1 minus 1 upon z. Okay, so a, b, c are in AP, which means that 1 upon x, 1 upon y, and 1 upon c will also be in AP, right? So that's obvious reasoning, because you just kind of multiply by some common thing. So suppose you multiply by this common thing to get this common thing. So yeah, you will eventually get that negative 1 by x, negative 1 by v, and negative 1 by z are in an AP. So that gives us that 1 by x, 1 by v, and 1 by z are also in an AP. So that's the definition of a harmonic progression. The reciprocals of x, y, z are in arithmetic progression. So yeah, x, y, z are in harmonic progression. Easy. So let's go to the next question. The first term of an infinite geometric progression is x. And its sum is 5, 10. Okay, so the first term of an infinite geometric progression is x. So you have x, then you have xr, then you have xr squared, where these r is supposed to be less than 1. I mean, modulus of r is supposed to be less than 1, because otherwise this, when you just add this up, this will like diverge to infinity something. So the sum won't be a finite value, which is 5 in this case. So we can apply this formula, x upon 1 minus r is equals to 5. Okay, and you have this restriction that modulus of r is supposed to be less than 1, which is pretty much the same as saying that r squared is less than 1, which is pretty much the same as saying r minus 1 into r plus 1 is less than 0. And the solution to this thing is going to be r belongs to r belongs to negative 1 to 1, and from this you can see that x is equal to 1 minus 5r. So because r belongs to this thing, you can say that minus 5r belongs to, well, minus 5 times 1 is minus 5, minus 5 times 1 is 5. Okay, so 1 minus 5r would belong to, when you just add 1 to both of these, so 1 minus 5r belongs to minus 4 to 6. Okay, so that should work, but that's not there. Infinite geometric progression is x and the sum is 5. It's supposed to be 5 minus 5r. Oh, sorry. 5 minus 5r. Yeah, correct. So yes, so you were supposed to get minus 5 and 5. When you add 5 to this, you just get 0 and you get 10. So which option is this? X is supposed to lie between 0 and 10. You have this option, correct. Okay, cool. Let's go to the next question. So let x be equal to this thing, log base 0.4 of 1 by 3 plus 1 by 3 squared plus, wow, okay, this the value of 0.16 to the xth power is okay, let's just do this. So what I'm going to do is that I'm going to um, zero point 0.4 to these powers, so that should still be an equality. So you will get 0.4 raised to the x power is going to be equal to 1 by 3 plus 1 by 3 squared till infinity, which is nothing but 1 by 3 upon 1 minus 1 by 3, which is 1 by 2. Yeah, right. So what do we get? Just square this, right? So when you square this, you get 0.16 to the x power is supposed to be equal to 1 by 4. Right? That's nice. So the first option is correct. Okay. The next question is the value of 9 to the 1 by 3. I think we have done this question. Yeah, I'm pretty sure. So what is this? 9 to the 1 by 3 plus 1 by 9 plus 1 by 27 and keeps on going like this. Well, this series is pretty much the same as this series, which is 9 to the half, which is 3. Yes, we did do this question once, I think in this video itself. The next question is the value of x to the log base b of a, where a equals to 0.2 and b equals to root 5 and x equals to 1 by 4 plus 1 by 8. Just find x first of all. So x equals to 1 by 4 upon 1 minus 1 by 2, multiply by 4, so you get 4 upon 4 minus 2 is nothing but 2, so it's supposed to be, what is it, it's 2, right? So x is 2, so you just get 2 to the log base root 5 of, what is this, of 0.2, which is 1 by 5. Wow. Okay, this is supposed to be 2 to the log base root 5 of root 5 raised to the negative 2 powers. This is supposed to be 2 raised to negative 2 power, which is 1 by 4. Yeah, is this correct? Wait, see this once again. It's supposed to be 2, I think. No, obviously not, because this is shit. This is not a 4, this is 1 basically. So this is not 2, this is 1 by 2. I should stop making these mistakes, but I'm not. Yeah, actually, yeah, this is just completely messed up. Okay, so this is not 1 by, this is 1 by 2. This is 1 by 2 raised to the negative 2 power, which is not 1 by 4 but 4. Okay, so this is the fourth option. Let's move on. If S denotes the sum to infinity and Sn the sum of n terms of the series 1 plus half plus 1/4 so on, such that S minus Sn is less than 1 by 1000, then the least value of n is, oh, okay, so S minus Sn is less than 1 by 1000. S is going to be 2, because we know that, whereas Sn is less than 1 by 1000. What is Sn? Sn is going to be, well, the first term is 1, and then you have r to the n, which is half to the nth power minus 1 upon half minus 1, which is just negative half. So you get this thing, right? It's supposed to be less than 1 by 1000, right? So what do you get from that? This is less than 1 by 1000. You get 2 plus half to the n plus 1 power minus half, but no, something went wrong. You're dividing, so n minus 1 power minus 2 is less than 1 by 1000. Yeah, that's more like it. Yes, so that's nice. You divide by 1 by 2, so this cancels, so you have half raised to n plus 1 power is less than 1 by 1000. So what can you do from that? What we can do is that we can take the reciprocal and flip the inequality. So you get greater than 1000, 2 raised to n minus 1 power. Okay, I think we know the perfect exponent of 2 such that it is slightly greater than 1000. So 2 raised to the 10th power is 1024, which is greater than 1000. So you can already make the connection that n minus 1 is supposed to be 10, so n is supposed to be 11. Okay, then the least value of n is 11, as we expected. Okay, so the next question is the sum of 10 terms of the series x plus. Oh shit, we have already done this question once. I don't want to do it once again. Actually, yeah, that's it. We have already done this question once. This is supposed to be this question. Yeah, correct. Yep, I think so. Or maybe we have not done this question once. Whatever, I'll just do this once again. We'll just do this once again. Okay, so you have x squared plus x to the 4th till 10 terms plus 1 by x squared plus 1 by x to the 4th 10 terms of these, and then you have 2 2 2 2 10 of these 2, so it's supposed to be 20. What's this thing? This thing is x squared times, well, x raised to 20 minus 1 upon x squared minus 1, and then you get almost the same thing over here, but this, what did I do? Okay, plus 1 over x squared times this thing. No, 1 over x squared times 1 over x raised to 20 minus 1 upon 1 over x squared minus 1. So that would be times 1 over x raised to 18. Yes, correct. And then that times 1 over x squared will be 1 over x raised to 20. So this is supposed to be 1 over x raised to 20 times all this stuff. So it's dot to dot. Yes, so x squared plus 1 over x raised to 20 is nothing but x to the 22 plus 1 over x to the 20 times x to the 20 minus 1 upon x squared minus 1, and then plus 20. So obviously option A is correct. And yes, we have already done this question once because we got the correct answer in a single try. Okay, if 0 is, oh shit, we have done this question once. I'm not doing this once again. No, we have done this question once. Okay, if sum of 3 terms of a GP is S, product is P, and sum of its reciprocal is R. Okay, sum of the reciprocal of its terms is R, then the value of P squared R cubed is equal to what? Okay, so suppose these 3 terms are A upon R, A and AR. You obviously have product equals to S, right? So you have A cubed is equal to S. The sum is R, so A times 1 by R plus 1 plus R is sum of reciprocals is R, and no, so this is, oh sorry, this sum is S. Okay, the sum is S, the product is P. Oh, what is this thing? This is P, and the reciprocals, which is going to be yes, it's going to be 1 upon A into R plus 1 by R. That is going to be equal to, what is it? R. Okay, that's cool. So what are we supposed to prove? What is P squared times R cubed? So R cubed times P squared, that's going to be S cubed, I think. Yeah, that was easy, right? So R cubed, you just get 1 upon A cubed and then this thing cubed, then that times A to the 6th power would give us A cubed. So A cubed times this thing cubed is the same as this thing cubed, which is S cubed. So that's easy. B is the correct answer. Oh wait, this question we have already done once. No, wait, I think, no, this question is new maybe. Yeah, so a ball falls from height of 100 meters, okay, and if in each rebound it describes 4/5 the height of previous falling height, and the total distance traveled by the ball before it comes to rest is, okay, so you will get 2 into 4/5 of 100 plus 2 into 4/5 squared of 100 and sorry what of 100. Okay, and then keeps going like that. It's supposed to be 100 plus what is this, 20, right? So 20 into what is this, 24 is 8, so 160 into 1 plus 4 by 5 plus 4 by 5 squared, keeps on going like that, plus 100 plus 160 into 1 upon 1 minus 4 by 5 is supposed to be 1 by 5, so 160 into 5, that is 8, yeah, so 80 I think, so 800, yeah, that should work. That's 800, right, into 5, that looks correct. So 800 plus 100 is just 900 I think, so that's correct. Yeah, there was this 1000 meters as well, and I think some people would have chosen 1000 meters because they thought that this first 100 meters was also to be taken twice, but no, that's not how it should have been done. That is supposed to be taken only once. Okay, if the first term of a decreasing infinite GP is 1 and sum is s, okay, first term is 1, sum is s, and then the sum of its squares of its term is, so this does not look that difficult to do. So the sum of the squares is going to be a squared upon 1 minus r squared. We know that the sum is s, so a upon 1 minus r is s, because this is a decreasing GP, infinite. Okay, the first term is 1, so instead of this a, just write 1 over there. So what is this going to be? Okay, just find r first of all. This will give us 1 minus r is equals to 1 upon s, so r equals to 1 minus 1 upon s, which is s minus 1 upon s. Just put this in this quantity, so you get 1 upon 1 minus s minus 1 upon s squared, which is s squared upon what is this thing, s squared minus s squared minus s minus 1 squared. Yeah, what is that? That's going to be 1 into 2s minus 1, so s squared upon 2s minus 1. Which option is that? Yes, this one, that's correct. Let's erase this now. Okay, a geometric progression consists of an even number of terms. The sum of all the terms is 3 times that of the odd terms. Oh, sum of all the all the terms is 3 times that of odd terms. The common ratio of the progression is, okay, consists of even number of terms. So that's nice. So let's do this. Suppose there are 2n terms in this sequence. Sum of all the terms, that's going to be a times the ratio, which is this time is going to be 2n minus 1 upon r minus 1. So the ratio, number of terms, and then the formula. This thing, sum of all the terms, is 3 times that of the odd terms. The odd terms, the first term is going to be a. In this sum of odd terms, the ratio is going to be r squared. Okay, so ratio is going to be r squared. How many terms are there going to be? Yep, n terms, right? N terms. So r is to 2n minus 1 upon r squared minus 1. Okay, that's cool. So this cancels, this also cancels. One of these factors will cancel. Alright, so you will just have 1 is equal to 3 upon r plus 1, which means that r is equals to 2. Easy. Okay, so the common ratio of the progression is 2. The next question is, if the sum of an infinite GP is x, okay, and the sum of the squares of its terms is y, then the common ratio is too easy. So what do you get? You get a upon 1 minus r is equals to x, and a squared upon 1 minus r squared equals to y squared. Wait, what? No, is equals to y. Okay, so you square this, you get a squared upon 1 minus r whole squared equals to x squared. You divide, so you get, well, you divide by this, so you take a reciprocal and multiply, so you get 1 minus r squared upon 1 minus r squared. That's going to be equal to, when you divide by this thing, right? So x squared upon y. Yes, that's correct. So that will give us 1 plus r upon 1 minus r. So now you can use componendo dividendo on this thing. So you'll get x squared minus y upon x squared plus y. That's going to be 1 plus r minus of 1 minus r, which is 2r upon their sum, right? Which is 2, which is r itself. So r equals to x squared minus y upon x squared plus y. Let's see if this is in options. Yes, it is. Okay, the next question is, if 1 plus r squared all the way to n, okay, r to the n, so there are n plus 1 terms in this, is equals to 1 plus r times 1 plus r squared times 1 plus r to the 4th times 1 plus r to the 8th. Okay, then the value of n is, wow, I mean, wow, what do we do with this? 1 plus r into 1 plus r squared. There are only 4 terms, maybe we can actually try to no, that can get very bad so soon, so let's not do that. That won't be nice either. Okay, there's supposed to be something which we can do. We can get 1 minus r. Oh, okay, that's easy, not too bad. So what is this? This is going to be r to the n plus 1 minus 1 upon r minus 1 is equal to 1 plus r into 1 plus r squared all the way till 1 plus r to the 8th power. Now watch carefully. It's going to be 1 minus r to the n plus 1, just multiply by negative 1. 1 minus r, why 1 multiply by negative 1? R to the n plus 1 minus 1. R minus 1 times this thing is going to be r squared minus 1, and then this is going to be multiplied by r squared plus 1 and all the other stuff, which is going to be r to the 4th minus 1 times r to the 4th minus 1 and all the remaining stuff, which is going to be r to the 8th minus 1 times r to the 8th minus 1, which is going to be r to the 16 minus 1 and all the remaining stuff, which is nothing is left now, so we just get r to the 16 minus 1, like that. Easy. So what do you get from that? Yeah, n plus 1 is supposed to be equal to 16, so n is going to be 15. Easy as that. Okay, the next question is, the sum of 10 terms of the series 0.7 plus 0.77 plus 0.777 is, too bad, we already done these kind of questions once, but whatever, let's just do this once again. So you get 7 by 9 of 10 minus 1 upon 10 plus 100 minus 1 upon 100. It keeps on going like that, and it's till 10 terms, so these are 10 terms. That's 7 by 9. How many of 1s do you get? I mean, 10 by 10 is 1, 100 by 100 is 1. These ones, you get 10 of them, and then you have minus of 1 by 10, 1 by 100, 1 by 1000, stuff like that. It's supposed to be 1 by 10 upon 1 minus 1 by 10, which is 9 by 10. So this is supposed to be 9. This complete thing can be written as 9. So 10 minus 9 is just 1. So did we do something wrong? 1 by 10. Oh yeah, obviously that's not an infinite GP, so that's why it was wrong. Okay, minus 1 by 10, the first term, times 1 by 10 to the 10th power, because there are 10 terms, minus 1 upon 1 by 10 minus 1. Just erase everything else, just some more space. It is going to be equal to 7 by 9 of, let's see what we get, multiply by 10. So 10 minus, well, this is gone, this is 10 minus 1 is just 9, so 10 minus 1 by 9 of 10 to the negative 10 minus 1, which is 7 by 81 of, well, what is it? um, yes, you get 9 over there. That's not too bad. So here just multiply by 9, so you get 90 minus 10 to the negative 10, then plus 1, I think so. Oops, this is supposed to be minus 1 is plus. Yeah, so plus of this thing and then minus of this thing. Looks more like it. Yeah, that looks correct. Okay, so this is supposed to be 7 by 81 of 91. So sorry, not 91. It's supposed to be 89 plus 10 to the negative 10. 10 to the negative 10. Is it in options? Yes, this is the option which we are looking for. 7 by 81, 89, and 1 by 10 to is 10 to the negative 10. Same thing. The sum of the first n terms of an AP is half the sum of the next n terms. In the usual notation, the value of S3n upon Sn is. Okay, so the first n terms of an AP is supposed to be is equal to sum of the next n terms. Suppose this is ar square, alternating ar to the n minus 1. These are the first n terms, and you have ar to the n power, ar to the n plus 1 power, and keeps on going with it till you get ar to the what, 2n minus 1 power, right? So these are the next n terms. So the sum of these terms, what is that going to be? That's going to be a times r to the n minus 1 upon r minus 1. What is that? Is half the sum of the next n term. So half a times r to the n, the first term, times r to the n minus 1 upon r minus 1. So this cancels this cancels as well. So you have r to the n is equals to 2. Not bad. So the sum of the sum of first 3 n terms upon sum of n terms is, wow, this is a bad one. Okay, so the sum of the first 3 n terms, what is this? Sum of the first 3 n terms is going to be a times r to the, well, what, r to the 3n, right? So because there are 3 n terms, and then r minus 1, and then sum of n terms is a times r is to n minus 1 upon r minus 1. So just divide them. So our required answer is supposed to be equal to s upon 3n upon s of n is going to be equal to r raised to 3n minus 1 upon r raised to n minus 1, and we already know what the value of r raised to n is going to be. So this is just 2 cubed minus 1, which is 8 minus 1, just 7, upon 2 minus 1, just 1. So that's the value. Is that correct? Doesn't look so correct. Well, this r raised to n is 2. And did I mess up something? I don't know, maybe the value of r raised to n is not 2. Okay, just do this once again to check if what I did was wrong or not. Why am I getting 7 over there? Okay, whatever. So you have a into r to the n minus 1 upon r minus 1. This is equal to half times a into r raised to n minus 1 upon r minus 1. Actually, a times r raised to n. Right, that's the first term. That looks correct. Yes, that looks correct. Cancels. This also cancels. Yes, r raised to n is 2. There should be no problem with this, and then 7 should be the correct answer. Whatever, just skip this question for now. Maybe I'm making some mistake and not realizing it. Whatever, just go to the next question. How much of it is left? Wow, quite a bit, huh? Okay, let's try to do it faster. Let's come. Okay, let an be equal to 1111 n times the remainder when a sub 124 is divided by 271 is. Wow. Never thought this would also contain some number theory problems, but okay, that's nice. So divide by 271. 271. What's the deal with 271? Can I write it in some way by what's so special about 271? Obviously don't want to do this manually. That would be not a smart thing to do. So there are 124 of them. Let's see what happens when you multiply 271 by something. What remainder do you get? So 271 times 1 is obviously 271. 271 times 2 is this having no, no, that's not what it is. Times 2 is 4, so it's 2, it's 14, 1 carried on, 4, 5, 42, 271 into 3, 3, 1, 2 carried on, 6, 813, 271 into 4, so it be 4 and then 8, it's not working, 271 into 5, okay, this might work, this just might work, 5 and then, what is this thing, 5, 7 5s are 35, 3 carried on, 10, so you have 1354. Not working. Well, 7 into 7, that won't work. 6, no. 8, nah, that won't work either. So that's not working. Okay. What about I write it as 111 plus 1 something like that? There has to be something special about 271. Is this a multiple of 3? Well, no, it's not. Um, is this a prime number or what is it? Is it composite? What's so special about 271 which we can utilize? 271, and I can keep going like that, but it won't give me anything. So you have to try something different, but exactly what? 271. Yeah, some of these numbers end up to 10. It's not a good sign though. Okay, T71 divided by is 23, 25, 27. Wow. How do we do this? I'm seeing nothing. I mean, is this even doable? Supposed to be some way of doing it. 271, 200 plus 70 plus 1. Oh, this is not working. You can keep going like this, but I don't think it's getting us anywhere. What about 9? 9 won't work. No, that doesn't work very well. What about some factors? Let's see if it has some factors. 11, no, it doesn't work. What about 13? 13, 26, 11, nah, doesn't work. About 15, 17, 1, 0, nah, that's not working. Okay. What about 19, 20, 21, 21? No, it's not working. Okay, so this is okay. So that's it. It's a prime number because this is not divisible by a lot of things. This is supposed to be a prime number now. What do we do with this? Dividing by a prime number, and we absolutely don't know anything about it. Okay. Oh, come on. What do we do? Just divided by this thing. Okay, this is not working. It's 29. Is this something else? Now there's only one way left. Just try to actually manually do it and see if we get any kind of pattern. Because when everything else fails, that's what we do. So we had 1 1 1 1. We just put a lot of ones over there. Got 271. Let's create 271, the whole multiplication table once again. So 4, say 271 into 5, maybe that will work. No, that will be too big. So into 4, this gives me 428. To carry down, yeah, 1084. Right, so just put 4 over there, is minus 1084. You get 11 minus 4 is 7, and then it's 270. Wait, what? Oh, that's weird. Wow, I was not expecting this, huh? So you do get this thing 1 1 1 1 1. That's supposed to be equal to 41 times 271. Go ahead, try it. You will see this is pretty amazing, huh? So how many of them? 1 2 3 4 5, and then we want to divide 124 of these. Okay, so just think of it, 1 1 1 1 1. Okay, that's nice. The first 120 of them you will be able to divide pretty easily. The last 4, 1 2 3 4, these will be the ones which will give you a remainder. So we want to divide 1111 by 271. Let's see what we get. First of all, you put down a 4, just like always. What was this? 4 8 0 28, so 8, yeah, supposed to be equal to 271, I guess, but no, sorry, 27, yeah. So that's correct. 27 is the answer. Man, this is a crazy good question. Yeah, that is a good question. We were on the right track at the very start itself, but it was just so tedious that we could not have done that. 41? 271 times 41? That gives me 1, I mean 5 times 1. So we could not have gone there just by hit and try. Okay, let's do the next question. If x equals to a plus a by r plus a by r squared all the way to infinity, y equals to b minus b by r all the way to infinity, and z equals to c plus c by r. Oh, that's boring. Then xy by z is simplified to. Okay, let's just do this. So xy by z, right? So x is equals to, well, suppose the ratio is having its modulus less than 1, right? Then it would be a upon 1 minus r. Y would be b upon, well, alternate terms, so it's only 1 plus r, right? Alternate negative terms, z is going to be equal to c. Oh, so squares. Okay, so the ratio is squared this time. So c upon 1 plus r squared. Sorry, not 1 plus r squared, 1 minus r squared. You can already see the connection. 1 minus r times 1 plus r is 1 minus r squared. Alright, so just multiply by x. Just do this. Xy times z. Xy upon z. So x into y is going to be, x into y upon z. It's going to be ab upon 1 minus r squared upon c upon 1 minus r squared, which is nothing but ab upon c. So this simplifies to ab upon c. Okay. The solution of the equation 8 to 1 plus modulus of cosine of x plus cos squared of x, the modulus of that, plus the modulus of cos cube of x, so on forever. That thing is 4 cubed in the interval negative pi to pi r. Let's see what we can do. So one of the things which you can see is that this modulus of cos x, if you multiply it by itself, that will give us the modulus of cos x squared, but because it is okay, so at every even power of cos squared x you can just ignore the modulus because that doesn't make sense. So yes, I think so. Okay, so here's what we can do. We can write it as 1 plus modulus of cos x plus modulus of cos x squared plus modulus of cos x cubed plus modulus of cos x to the fourth power, right? So we can just bring that power out of the modulus, and still it will make no changes in the quantity. So that will be a good move. So in that way we get 8 times 1 plus, say modulus of cos x is equal to r. So you get r plus r squared all the way till infinite terms is equal to 4 cubed. And you can see that from this very fact r is going to be less than or equal to 1. Alright, but this cannot be equal to 1 because we are looking for solutions in this interval. So cos x can be 1 only when it is at 0. Okay, at 0. So minus pi to pi, but it can be 0, but that won't be a solution. So we're just assuming that r is less than 1 and not equal to 1. So modulus of cos x is not equal to 1, I mean obviously. Okay, so from that we can say that 8 and then 1 over 1 minus r is equals to 4 cubed. Okay, well, that means that what can we do? 2 to the 3 upon 1 minus r is equals to 2 to the 9th power. So you get 1 upon 1 minus r is equals to 3. So what do you get? You get 1 by 3 equals to 1 minus r. So r equals to 1 minus 1 by 3 is equals to 2 by 3. Okay, that is nice. So you got r is equals to 2 by 3. What can we do from that? Yeah, so just put that in that our assumption thing. So r equals to 2 by 3 means that modulus of cos x is 2 by 3, which also means that cos squared x is equals to 2 by 3 squared. Is this 2 by 3? And something is completely wrong. 2 by 3 is not looking good. If it were 1 by 2 or something, that would be, I think we did it wrong. Okay, so 8 and then 1 over 1 minus r equals to 4 to the third power. 2 to 3 upon 1 minus r is equals to, oh yeah, obviously 2 to the 6th power. We did it wrong completely. 1 minus 1 by r is equals to 2. So 1 minus r equals to 1 by 2. So r is equals to 1 by 2 itself. So that makes more sense. So modulus of cos x is equals to 1 by 2. Okay, which is equivalent of saying that cos squared of x equals to 1 by 2 squared, or the cos square of 1 by 2, so pi by 3, which means that x equals to, well, instead of doing all this formally, we just draw a unit circle. That will be better to understand. So suppose this is your unit circle, this is your negative pi, alright, and then you move like this and you land over here, and then it will be a positive pi. We want to find when is the modulus of cos x equals to half, which means that cos x can be minus half or positive half, both will work. So it is over here, over here, over here, and over here. Yes, yeah, there are a bunch of values for this. Yeah, there are not only 2 solutions, there are actually 4 solutions, but oh, so there are plus minus over there. Okay, that's why it's different. Okay, cool. So the first value which we will meet is when you put this as 60 degrees or as pi by 3. Okay, so you just get minus pi plus pi by 3, which is minus 2 pi by 3. That's the first value over here. Then you get minus pi, this is supposed to be 0, alright, this is supposed to be pi by 3. This is minus pi by 3. Okay, this point is corresponding to minus pi by 3. This is minus 2 pi by 3. Then you move pi by 3 up, so you get plus pi by 3, and then you eventually get pi minus pi by 3, which is 2 pi by 3. So yes, plus minus 2 pi by 3 and plus minus pi by 3, that should be our answer. So C is the correct answer. Okay, that was good. Oh, come on, not now. Why the heck is this? Oh, really? Okay, sorry for that, but okay, whatever, just move. Okay, if the sum of if the sum to n terms of a series be 3 times 2 to the n minus 1, then it is oh okay, sum of n terms. Okay, so here we go. Sum to n terms of a series. So this is going to be okay, this is going to be the first term plus the second term all the way till n terms. That's going to be 3 times 2 raised to n minus 1. Now we also want to know what will be the sum till n minus 1 terms of this series. But using this very formula and putting the value of n as n minus 1, alright, you get it as 3 times 2 raised to n minus 1 minus 1. Okay, so now just put this as well. So when you subtract these two equations, you just get an, which is the nth term of this series. This is going to be 3 times 2 raised to n minus 1 minus 3 times 2 raised to n minus 1 minus 1, which can be written as 3 times 2 into 2 raised to n minus 1 minus 2 raised to n minus 1, which is equal to, well, only 1 times of that, so 3 times 2 raised to n minus 1. So yeah, this is supposed to be a GP. Alright, yes, this is a GP with the first term being 3 and the ratio being 2. Okay, so where's that question? Yeah, then it is a geometric progression like that. Okay, if ABC are in AP, x is equals to 1 plus a plus a squared all the way till infinite terms, and y equals to 1 plus b squared, so on, and z equals to 1 plus c plus, okay, cool, where, okay, yeah, that condition is necessary, and x, y, z are in, I think, oh, this is the same as the previous question, right? So this is supposed to be harmonic progression. We already did this once, right, in this video itself. If the sum of infinite GP, okay, is 20 and the sum of their squares is 100, then common ratio will be, okay, that's easy. A upon 1 minus r is 20 and a squared upon 1 minus r squared is 100. I just square this, so a squared upon 1 minus r whole square is 400. Just divide, so what's equal to 4? 1 minus r squared upon 1 minus r whole squared, so you get 1 plus r upon 1 minus r equals to 4, which means that 1 plus r is equals to 4 minus 4r, so you have 5r is equals to 3, or r is equals to 3 by 5. Okay, so yeah, that's correct. What are we supposed to find? The common ratio is 3 by 5. Okay, that's nice. The next question is, if x equals to the summation from n equals to 0 to infinity of a to the nth power, and then y equals to, okay, this thing, but with b this time, and then z equals to this thing, z. Okay, this is almost the same as the previous question, where a, b, c are in AP, and oh, come on, this is the same question as this 59th one. So yeah, it's supposed to be harmonic progression like that. X, y, z are in harmonic progression. Too easy. Okay, if 100 times the 100 term of an AP with non-zero common difference equals the 50 times its 50th term, Okay, if 100 times the 100th term of an AP. So this is supposed to be equal to 100 times a and then r to the 99 power is equal to with non-zero common difference equals 50 times the 50th term. Okay, a r raised to the 49th power, then the 150th term of this AP is, wow, this is not too bad. So this is supposed to be r raised to 50th power is 1 by 2. That's one of the good equations which you can get. Okay, then we want to find what the 150th term of this sequence. So 150 times 50, oh, there are a lot of things. So the 150th term is going to be a times r raised to 149. Yeah, 149, which is what can you say about this thing? R raised to 50 is half, right? So this is going to be 1. Okay, so this is going to be r to the 100, which is 1 by 4 times a raised to r to the 49, which is 1/4 of the 50th term. Okay, that's nice. I think so. This is nice. Yeah, it looks correct to me. So you have some options: 150 times the 50th term, 150, 0. Where's this option? What's the deal? Why is this option there? So you got the ratio. That is correct. What's wrong? Okay, so 1 by 2 squared is 1 by 4, and then you have this a times r to the 49 power. Well, it should work. I don't know, something is just not, it's not looking correct in this. Okay, whatever, let's move on. I think the options are wrong, because no, I don't think my solution is wrong this time. I think the options are wrong. Just move to the next question. The sum of the first 20 terms of the sequence 0.7 points. Oh, come on, really? I'm not doing this. Okay, the value of 0.2. Really? Oh, this is the same question as from before, just with the values already put in this time. Let's just do this right now. So 7th 1 by 5 raised to log base root 5 of this thing is supposed to be well, what is this? 1 by 4 plus 1 by 8 plus 1 by 16, so on. It's supposed to be equal to 1 by 4 upon 1 minus 1 by 2, which is 1 by 2 itself. So okay, that's cool. Okay, so what I'm going to do is that I'm going to write it as root 5 raised to negative 2, and then this complete raised to this power, which can also be written as root 5 raised to this power, and then this raised to negative 2, which is going to be half to the negative 2 power, which is 4. Yep, this value is going to be 4. Exactly the same as the previous question. I mean, one of the already questions which we have already done. So the next question. So if n approaches infinity, if the limit at n approaches infinity of 1 plus 1 by 3 into 1 plus 1 by 3 squared into 1 plus 1 by 3 to the 4th, oh god, this keeps on going like this, is equal to m by n, then m plus n is equal to, wow, okay, that's a good question. This is not exactly a GP. We need to bring it in the terms of a GP somehow. But how? Okay, so the denominators are in GP, so that's one of the things. And then you have 9 plus 1 is 10. So 82, that won't work very well. You do need to use something for this to happen. Okay, we know that it's going to eventually cut down to 1, right? And then it will converge to something, but how do we know what it will converge to? This is seriously weird. Okay, so 1 plus 1 by 3 into 1 plus 1 by 3 squared. I don't know, just see what we can do with it. Hey, wait, I remember something. We saw these a similar kind of question before, right? Okay, so suppose this is equal to x. Let's call this as x. 1 plus 1 by 3, 1 plus 1 by 3 squared, all the way. It keeps on going like that. What I'm going to do is that I'm going to multiply this by 1 minus 1 by 3, and it will click to you in a moment. So 1 minus 1 by 3 times this thing is 1 minus 1 by 3 squared times 1 plus 1 by 3 squared times all the remaining stuff, which is 1 minus 1 by 3 raised to the 4th power times 1 plus 1 by 3 raised to the 4th power times all the remaining stuff, which is, yeah, it keeps going like that till eventually you get to 1 minus 1 by 3 raised to infinity, which is just going to be 1 itself. So yeah, that's nice. This is really nice. It's a nice question. Okay, so this is supposed to be equal to m by n. Okay, yes. So what is this? This is 3 minus 1, which is 2. So 2/3 of x equals to 1. So x equals to 3 by 2. Okay, then m plus n is equals to, I suppose m and n are co-prime integers. So this is m, this is n, this is m. So m plus n is equal to 5. Is 5. Okay, evaluate 2 by 3 of, 2 by 3 plus 1 by 3 plus 2 by 3 cubed plus, I think we have done this question once, have we not? Let's do this fast. So what is going to be? 2 by 3, this is the first term, upon 1 minus 1 by 9 plus 1 by 3, 1 minus 1 by 9 multiplied by 9. So you get 6 upon 8 plus 3 upon 8, which is 9 upon 8. Nice. Okay, this one, 4th. Right, so 4th is going to be 4 by 7 upon, well, so ratio is 1 by 49, so 1 minus 1 by 49. And then subtract from it 5 by 49 upon 1 minus 1 by 49. Multiply by 49 on numerator denominator. That will give me, well, 4 times 7 is 28. 49 minus 1 is 48. Okay, and then minus 5 upon 48, which is 23 upon 48. So that looks correct. Okay, what other questions do we have? No, that's it. So this was it. Hope you enjoyed. See you later.